Okay, so today we'll be discussing about the counter current mechanism of a nephron. Uh, First, moving on to the parts of nephron, here we can see this, the blue one, what you see is the nephron. Okay, so it has mainly this Bowman's capsule. This, okay, I'll change the color. Hmm. Okay, so this is the Bowman's capsule. Here you can see this blue part. Then you can see this this part, the curved part, that's the PCT. So that is the proximal convoluted tubule. This convoluted word, this means curved. So here we can see two curved tubes, the PCT and the DCT. This one is the PCT and this another one here is the DCT. So this PCT, this joins the loop of Henle. This continues as the loop of Henle. This is the loop of Henle. This loop of Henle then continues as the DCT, and then it opens into this collecting duct. This collecting duct, this one here you can see. This actually is a duct in which many nephrons open up. So it's not a single nephron which is opening into the collecting duct. There are many. See, here you can see one, here you can see one, here you can see. So these are many nephrons which are opening up into the collecting duct, and finally this urine, this flows down and it goes out of the body. Okay, so okay, this red thing now, the red thing what you see here, this red thing is actually the blood vessel, what you see. So here the blood vessel, you can see afferent arteriole and the efferent arteriole. Okay, so telling about the afferent and efferent. Afferent means in, whereas efferent means out, which means the afferent arteriole will take the blood towards the glomerulus, towards the Bowman's capsule, and the efferent will move the blood out of the glomerulus. This network what you see here, this one, this network is the glomerulus. Glomerulus is nothing but the blood vessels form a network inside the Bowman's capsule, which is known as the glomerulus. This efferent arteriole then continues and it actually winds around all the different tubules, the PCT, loop of Henle, DCT. It winds around them, and then it goes to other part, the next nephron. So in this nephron you can see this it is also winding up around PCT, around loop of Henle, then around this DCT, and then it moves here. You can see it moves away from one nephron to go and supply the other nephron. Okay, moving on, what is counter current mechanism? See, counter current mechanism mainly consists of the coordination or the relationship between a nephron. This is a nephron here. Okay, second. This is a nephron here. This nephron and the vasa recta. Vasa recta is nothing but is the blood vessel what we saw in this slide. These blood vessels which are winding up around these blood vessels, these are known as vasa recta. Vasa recta is actually the blood vessels which are moving along with the nephron, like. Okay. So now this counter current mechanism. Counter current mechanism, in this we can see same, the part of the nephrons. These this here, the part is the efferent arteriole with the glomerulus and Bowman's capsule. Here this part is the PCT, this long loop of Henle, then this the DCT, and finally this is the collecting duct. So if we see what are the osmolarity it actually depends on the filtration and reabsorption done by the nephron. As we know, the osmolality of the blood is 300 milliosmol. So when you see here this 300 is actually the osmolality in the glomerulus, that is of the blood, which will be filtered into the Bowman's capsule. So when it comes into the Bowman's capsule, the osmolality is 300, and after passing out of the nephron, the osmolality here, you can see the osmolality here is 1200. So you can see the urine gets concentrated as it moves down the different tubules and loop of Henle and then the collecting duct. So finally the urine which goes out of our body, that has an osmolality of 1200 milliosmol. It gets so much concentrated in the nephron. This nephron is actually, it preserves water in the body, because if this osmolality is not increased, then we will lose a lot amount of water, which will be very dangerous for our health. So this concentration is very much needed. Now when you see the osmolality, how it changes, this PCT actually, PCT is the main tubule which helps in reabsorption. So whatever blood is filtered out of the glomerulus to the Bowman's capsule, after moving out of PCT, the osmolality does not change, because the amount of water and the amount of sodium what is reabsorbed is almost or nearly the same. Osmolality can only change if there is disbalance between reabsorption of sodium and water. In PCT, the amount of sodium and water reabsorbed are almost the same. So the osmolality of the urine which comes out of PCT, that is this, is 300. That is, it is same as the osmolality of the blood or the glomerulus or the Bowman's capsule, what we say. Now moving on to loop of Henle. After coming out of PCT, the osmolality here we have taken, it's 300. That is fixed. It cannot be changed. Now this loop of Henle, in the loop of Henle, when we see there is ascending limb and a descending limb. This part, because we are going down, it is a descending limb, whereas we are going up, so this is an ascending limb. This descending limb, this descending limb, when we see this descending limb, the amount of water reabsorption what we see is much more. This descending limb of loop of Henle is actually impermeable to sodium, whereas it is fully permeable to water. So the water is reabsorbed, whereas sodium cannot be reabsorbed, due to which, because the water is going out of the tubule, out in the sense it is going into this blood vessel. This we will talk in a few minutes. Like first we will see about this descending limb. So it is fully permeable to water, so water goes out. As we know, when water moves out, the urine gets concentrated, because it's letting the water go out, whereas it is preserving sodium, and sodium is responsible for the osmolality. So here we can see it moves from 300, it goes to 400, then 600, 900, and finally here you can see it's 1200. So this has increased a lot. The concentration is much more at the end, whereas it was 300 at the beginning of this descending limb. Now if we see ascending limb, this one, ascending limb, here we can see the ascending limb of loop of Henle is actually permeable to sodium, whereas impermeable to water, due to which this concentration you can see, because it is losing sodium, it is losing osmolality. See, where there is more sodium, the osmolality is high. So if we are losing sodium, the osmolality decreases. Moving up in the ascending limb, from 1200 it goes to 7, 400, 200 and then 100. This osmolality, what we see here, this one, it is actually decreasing. Why? Because we are losing sodium. When sodium is lost, concentration is lost. So here we can see it's 100. Now